Why can the same fan deliver plenty of airflow on an open bench, but much less after you connect a filter and duct? The missing idea is static pressure. In the next 2 minutes, we will make it visible, measure it correctly, and use it to avoid a common fan selection mistake. Picture a sealed duct with a fan, a filter, and a pressure tap in the wall. The fan creates a pressure difference that pushes air through every restriction. Static pressure is the part of the air's pressure that acts in all directions at a point. In a duct system, it represents the pressure potential available to overcome resistance. It is not the airflow rate, and it is not simply the speed of the air. This is why a wall tap is drilled perpendicular to the flow. It senses static pressure without pointing into the moving air. A forward-facing probe also captures velocity pressure, so its reading is closer to total pressure. For low-speed air, total pressure is approximately static pressure plus velocity pressure. A U-tube or digital manometer converts the pressure difference into pascals or inches of water gauge. On the suction side, static pressure can be below the room reference. On the discharge side, it can be above the room reference. To report external static pressure across equipment, technicians measure at defined locations and apply the specified sign convention. Probe position, straight duct length, swirl, leaks, and the test method all affect the result. Now add a clean filter, a coil, 2 elbows, a grill, and a partly closed damper. Each component adds pressure loss at the design airflow. When the filter becomes dirty, the system curve gets steeper. The operating point moves, static pressure changes, and delivered airflow usually falls. The fan has not forgotten how to move air, the system is demanding more pressure. Here is a real Longwell high static pressure centrifugal fan from our NAS product media. Real hardware provides the pressure rise, but the required duty is defined by the complete system. A free air airflow number by itself does not tell you what the fan will deliver after installation. For selection, specify the required airflow and the required pressure at that airflow. Confirm whether the curve uses fan static pressure or fan total pressure, which density and speed apply, and which test method was used. Then check efficiency, absorbed power, sound, control range, inlet conditions, and motor limits at the operating point. The simple rule is this: airflow tells you how much air moves, static pressure tells you how hard the system is to push through. You need both values on the same verified curve. Review: longwellfans.com